Find the zeros of this function. Well, let's first test whether 1 and negative 1 work. So test 1. We're going to add all the coefficients up. 1 minus 4 minus 3 plus 10 plus 8. That's a lot of positives, so that's not going to add up to 0. Let's test negative 1. We change the sign of the coefficient on the odd degreed terms. So that becomes 1 plus 4 back to minus 3 minus the 10 and plus the 8, and those do add up to 0. And that tells us that negative 1 is a 0, and we can use synthetic division with negative 1 up there in the corner. Here's our 1, negative 4, negative 3, positive 10, positive 8. Bring down the leading coefficient. Negative 1 times 1 is negative 1. Add down to get negative 5. Negative 1 times negative 5 is positive 5. Add down to get 2. Negative 1 times 2 is negative 2. 10 minus 2 is 8. We're going to get a negative 8 right there and a 0 beneath. So that tells us we can rewrite our function as y equals x plus 1, and that's a plus 1 because we're changing signs when we're going from the 0 to the factored form, times x to the third minus 5x squared plus 2x plus 8. Okay, it's time to continue factoring, and I always like to try the 0 we just found a second time. So here we go with our coefficients, 1, negative 5, 2, and 8. Bring down our 1. Negative 1 times 1 is negative 1. Add down in the next column to get negative 6. Negative 1 times negative 6 is positive 6. Add down to get 8, and you can see that we've got a winner here. So negative 1 works a second time, and we can rewrite this as y equals x plus 1 quantity squared times x squared minus 6x plus 8. Now, the last parentheses contains a quadratic expression, and that can be factored in our heads at this point. So we will have x minus 2 and x minus 4. So our zeros are going to be negative 1, positive 2, and positive 4, and this negative 1 has a multiplicity of 2. We are now asked to solve this equation, and I'm going to solve it by graphing this time. We see that the numerator is going to have x equals negative 3 halves as an x-intercept. The denominator is going to have x equals 1/3 as a vertical asymptote. So let's graph just those two pieces to begin with. X equals negative 3 halves. That's negative 1.5 right there. And x equals 1/3. That's just going to be just a sliver to the right of the y-axis. We can substitute in 0 into the function and find out that when 0 goes in, we get 3 over negative 1, which gives us negative 3, and that becomes our y-intercept, which I'm going to plot now. Negative 3. And then we look at the degrees of our numerator and denominator. They're both a first power, so we're going to take the ratio of the leading coefficients, and y equals 2/3 will be our horizontal asymptote. So right around there. And that tells us we're going to have a curve down here in the bottom left and another curve up here in the top right. We are interested in where this is greater than or equal to 0, and we can see that it's greater than or equal to 0 over here on the far left. So we will have from negative infinity up to, that's a negative 3 halves, which we're going to include because that's the equal to part, and it's above everywhere over here to the right of, what is that? Sorry, that's not, yeah, to the right of the 1/3, so union parentheses 1/3 comma infinity.